Hi, good morning to all. Today we discuss about 2-point sources of same amplitude but opposite phase. That means the maximum value of field at the point P due to first source. Okay, at that case there will be minimum value of field at the point P due to other source. The reason is that the phase is opposite. So we can find the total phase difference psi is equal to beta d cos theta plus pi. Here beta d cos theta is the phase difference due to path difference and pi is due to the applied current phase. That is the relative phase between the sources are pi. That's why we call it as opposite phase. So the total electric field E can be computed as E is equal to E0 into E raised to minus j psi by 2 plus E0 into E raised to plus j psi by 2. From that you will get 2E0 into cos psi by 2. The normalized electric field En is equal to E by 2E0. That is equal to cos psi by 2. We know that psi is equal to beta d cos theta plus pi. Substitute that. Then you will get finally sine beta d cos theta by 2. We know that beta is equal to 2 pi by lambda. Substitute that. Final answer is sine pi by lambda into d cos theta. Next, we want to plot the radiation pattern. For that, we assume the distance between the antenna sources are lambda by 2. D is equal to lambda by 2. So, the normalized electric field En is equal to sine pi by 2 cos theta. By substituting D is equal to lambda by 2, you will get normalized electric field En is equal to sine pi by 2 cos theta. Next, we want to find it the maximum field point and the null points and half power points. First, we find the maximum field point. For that, we want to equate En to its maximum value. We know that it is a sine function. So, its maximum value is plus or minus 1. So, equate En to plus or minus 1. You will get theta is equal to 0 and 180 degree. Then, for null points, the sine value is minimum at 0. Then, solving that, you will get theta is equal to 90 and 270. Okay, we know that sine is 0, sine have 0 value at 0 and 180 degree. But here we consider 0 only. What is the reason? If we consider 180 degree, when we rearrange the equation, you will get cos theta is equal to 2. That is not physically realizable. That's why we remove 180 degree. We consider the 0 only. Okay. On solving, you will get theta is equal to 90 and 270. Then half power points. That means electric field intensity is 1 by root 2 of its maximum value. Here maximum value is 1 plus or minus 1. So En is equal to plus or minus 1 by root 2 at half power point. On solving the equation, you will get theta is equal to 60, 120, 240 and 300. Then we can plot the radiation pattern. Here the maximum at 0 and 180 degree, maximum value at 0 and 180 degree, and the null points at 90 and 270. Null points at 90 and 270, and the half power points occur at 60, 120, 240 and 300. So on connecting those points, you will get a radiation pattern like this, and this radiation pattern is known as end-fire radiation pattern. Okay. Next we can move on to the third case. Here we consider 2-point source of unequal amplitude and any phase difference. Here we consider 2-point source of unequal amplitude. So the electric field will be E1 and E2. They are different. And the phase difference is any phase difference. So the total phase difference psi can be represented as beta d cos theta plus delta. Delta is any phase difference. The resultant field can be written as E is equal to E1 into E raised to j psi by 2 plus E2 into E raised to j psi by 2. The psi is the phase difference between the sources. Next, we want to simplify this equation. For that, we displace the system in such a way that the source 1 is coincide with the origin. So what happened for this equation? Here, in this equation, we consider origin as the reference point and the source 1 and source 2 are the equal distance, that is d by 2 distance from the origin. And psi is the phase difference between the source, and we consider origin as the reference. So with respect to origin, the phase difference is psi by 2. That's why we use the psi by 2 in this equation. But here, for the simplicity, we move the first source to the origin. Source 1 is coincide with the origin. So here the reference point is the origin. At that point, the source 1 is placed. So we can say that with respect to the origin or source 1, the phase difference is 0. If we consider the second source is at a phase difference of psi from the origin. At that origin, the first source is placed. So here the phase difference is psi. You must check both these equations. The first equation, we consider the origin as the reference point and both the sources are at the equal distance d by 2 from the origin. But in the second case, the first source is displaced to the origin and that is the reference point. So there is no phase difference with respect to origin, that is due to first source. Then when we consider the second source, that is at a phase difference of psi from the first source at the origin. So the total electric field can be rewrite as E1 into e raised to j0 plus E2 into e raised to j psi. We can rearrange the equation. We take E1 outside. So the equation become E1 into 1 plus E2 by E1 into e raised to j psi, and it can be E2 by E1 can be written as k. Next, we know that e raised to j psi, we can written as cos psi plus j sin psi. So you will get electric field in terms of real term plus j into imaginary term. Next, we can find its magnitude. That is magnitude of E is equal to E1 into square root of 1 plus k cos psi the whole square plus k sin psi the whole square. Like that you can compute its phase also. And this magnitude term here 1 plus k into cos psi the whole square, this is equivalent to a plus b the whole square. So you can expand this equation. So you will get an equation like this one. From this equation, if you consider the second term and fourth term, from that you can take k square outside. So you will get cos square psi plus sin square psi, that is 1. So equation is reduced like this. Okay, that's all. Thank you.